Okay, let's get started. Welcome to this talk here right now by the Wolfram Technology Group. We'd like to label ourselves as your gateway to expertise in Wolfram technologies. My name is Fleck. I'm the manager of the team. And we'd like to kind of give you a few impressions of what we do in our team, how we do it, and how it's of benefit and value to you, okay? We have 4 subparts of this presentation, so you get a lot of value for the time, basically. The other speakers are sitting here in front of with me. There's Karl, Isensee, Michael Kelly, and Anshu, Manik, presenting the various sections here. And I will just quickly give you an overview before handing off to everybody else. Again, I will be covering the overview. So first of all, let me talk about what we do, what kind of, in which ways we provide expertise to you, okay? Our team grew out of technical support, where you've known beforehand the premise support, and what you've implicitly gotten for a long time was actually developer support. You know, it's not just installation support, not just IT stuff. You really get help with programming in the various Wolfram products. What we've added there recently, a couple of years ago, was enterprise support. Maybe that's not quite as known. At the same time, this is not the only thing we do. There's several more things, as you can see already in that list. We are the continuation of the Wolfram Education Group. We actually execute training. We create training. It can be done in various many ways. It can be a standard course that you do online, that you do in any location around the world. It can be something personal and custom. It can be, it can be for an entire team. It can be for an individual person. Next, we do sales engineering, meaning if you're not a customer yet and you don't, I'm sorry? Enlarge. Let's see if we can make it a little bit larger. Let's hope it will still fit. Is this better? Okay, good. Technical sales presentations means if you are not yet a customer, but you would like to find out what our technologies can do for you, then we'd be glad to come to you and give you a presentation that speaks of what will be the benefits and what will be the possible solutions to use various technology of ours. Furthermore, technical services is if you're not quite sure how to get something done, you don't have the time for it, but you feel like there's somebody in our team who can do it for you, we'd be glad to do it. Technical services is one of the 3 different consulting teams we have in our company compared to Math Core and to Wolfram Solutions. We're the ones who are closer to the code base. So if you have existing code, you have any changes that need to be done with it, or you'd like to have something from scratch, but in the end you'd like to understand what's going on, this is our team that you want to talk to. Furthermore, we take care of all the feedback that you give us on the various products. We lobby the R&D team on your behalf that stuff gets updated, gets improved, gets taken care of. One of the examples we had is actually the devices project that you might have heard about right now. We had gotten feedback from various potential customers. They would love to have data directly in the product, be able to use it, and, well, Stephen likes to solve things rather in the big way, so he just didn't feel like maybe just one way to kind of import data. He said, let's just do it all. So, but the impetus came from actually talking to us. Furthermore, we have certain online resources. I'd like to especially mention the support FAQs. The website basically where hopefully you can find certain answers to frequently asked questions or certain topics that come up time and again. The point is that we can update that site as necessary. As we become aware of an issue that happens to many of you, many of our users, we can update that and let you know as soon as we understand that something's happening. It's not the same release cycle as the various products. Technologies, what is the expertise we have? Impossible to enumerate on one slide or anything like that. I'd just like to flash the various products at you that we help you with, that we can help you with. It's everything on the Wolfram research side. It's not Wolfram Alpha, simplifyingly speaking. Last but not least, a quick, before I hand over to the next speaker, I'd like to show a little bit like what kind of challenges we have and how we try to adapt it, how we try to adapt to it. First, of course, the 6 areas that I just showed you, these are challenging by itself. There's a lot of technology in all the various products. At the same time, we have very, very interesting customers, okay, with very interesting problems. That doesn't make it any easier for us, okay? So our solutions here is to have very highly qualified team members. And I just like to flash a little bit of what diversity of background they have and the skill level that they have. And otherwise, I would talk a long time about like how I feel that my team members are very, very interesting and very helpful people. But I don't feel like I should waste that time right now. I'd rather like you to meet them and talk to them, okay? And this can be either through the various presentations that they've had already. We've done also all the training, well, a good part of the training on Tuesday, including from Millie, who's sitting over there, and she will also give another presentation right after this presentation here right now, or by, I think, Chinkao, for example. But in any case, unfortunately, many of these things have passed already. But I'd really encourage you to listen to whoever's going to follow me right now, or Millie right after this presentation.
Well, hopefully everyone can hear me. Like Peter said, my name's Karl Isensee, and I'll be responsible for the technical support section of this talk. And I do think it's important to discuss technical support because, to put it bluntly, technical support at Wolfram Research is simply different than technical support at many other companies. And a good hint that it's different than technical support at many other companies is just in who's doing it here at Wolfram Research. You know, we aren't hiring people, you know, from the local high school. We aren't hiring people even from across the street at the University of Illinois. You know, the people doing technical support here at Wolfram Research oftentimes have PhDs. I have a PhD in astrophysics. I'd say roughly maybe half the department has PhDs. Many of the rest of the department has master's degrees. So we're talking about people who generally have advanced degrees in some area of science, engineering, mathematics. These people have technical backgrounds in science, usually with some kind of programming background. So that's one good hint that what we're doing is quite a bit different than what people generally associate with technical support. All right, so what exactly do we do? Well, we really are essentially a central department here at Wolfram Research, and that's kind of one theme I want to bring up as I'm going through this section over and over again. In that, yes, we're communicating with the public, and that's very important, but as you communicate with us, what you should be realizing is that we communicate with many different departments here at Wolfram Research. So we're certainly communicating with QA. You know, the feedback you give us is certainly communicating to QA. We're also communicating with developers directly, and this communication can go multiple ways in that, you know, we might get information from our developer and pass it on to you. But, you know, we might also be passing information from you, the user, onto our developer. So if you find a problem in Mathematica or you have a suggestion for existing functionality, we can pass that information onto a developer. So that communication can go both ways. And we also can communicate with management. So for example, especially when we're releasing new products, which is something we're doing a lot recently, for example, the Wolfram Cloud, we communicate with our management all the time directly in technical support. So I know that when we released the Wolfram Cloud, pretty much every week we would have a meeting where management would ask, okay, what are the users saying about the Wolfram Cloud? Are they encountering any problems? What suggestions for improvements are they making on a weekly basis? You know, what do they have to say? And we give that feedback directly to management, and they can disseminate that information to developers working underneath them. So we really are kind of a central unit here at Wolfram Research, and therefore communicating with us, you know, as the public is very important. And so we really do act as this central conduit. Okay, so this is, you know, much of this is repetition from what Peter has said, but we really do support a huge range of products. There are almost as many products as there are people in technical support. We're responsible for a lot of different types of questions. This can range all the way from installation questions, which can essentially be, you know, put the DVD in the drive and make it go, all the way up to complicated programming questions. So we cover a huge range of questions, which means that we're essentially talking to a huge range of people. This can go all the way from, you know, professors, including people who have won, you know, prestigious awards, you know, people, very prestigious people and famous people in industry, all the way down to students and their parents who are frankly, not as competent as some of these other people. And so we have to be able to communicate with a huge swath of people with different abilities. And these people come from a wide variety of different domains. They might have an IT background, they might have a mathematics background, they might have an engineering background, they might have just a general kind of programming and industry background. And we communicate with these people in different channels. So the main point here is that there's, for an engineer like myself, there's really no way that we can communicate with all these different people, about all these different products and be an expert in every one of these areas. But because we are an expert on Wolfram products in general, we can pretty much always say something useful to all of our users about whatever questions they have and give them some information to begin with. And then even if we can't answer their question completely to begin with, even though we're giving them some useful information, we can at least communicate with our developers, get back to them, and then within a short amount of time, get them additional useful information. So we get them started on the problem a lot of times, even if we don't have their exact domain-specific knowledge. And then we talk to a developer and get them additional information at a later point in time to get their problem completely solved. And so that's kind of the general workflow that we seek to do in the technical support department. So we've been speaking in terms of kind of abstract and a little bit of hand waving here. So let's look at some kind of a specific case, a couple specific cases that we've encountered in the past. And so these are pretty simple cases because the point isn't really to demonstrate how clever we are or anything like that. The point is to show just our general workflows. So we shouldn't get caught up in the details of these cases because frankly they're not very complicated. We should be just examining the workflows of how we work in technical support. So this was an issue that came in the Mathematica 9 days, and this is about control system engineering, specifically the root locus plot function. Now, to speak to what I was talking about in the previous slide, my background is in astronomy, so frankly, I don't know a lot about root locus plots. I'm not a control system engineer, and if this really came down to how to, what are the details of interpreting a root locus plot, I might be in a little bit of trouble here. But I do know a whole lot about visualization in Mathematica, and I am, an expert in that. So what a user did is they came in with this question of, they said, okay, this is what Mathematica does, and this is what Mathematica comes up with in Mathematica 9. If you just basically give it this generic root locus plot, and they said, okay, this doesn't look quite right with just essentially default options. This should be more circular down here, essentially, and not quite as filled in along the axis. And so the question is, they asked me, okay, how can you make this look a little bit better? And so I can give them a little bit of information right away. I could point out, okay, basic plotting in Mathematica, you might have to tweak some options, like you might have a plot points option. You might, and for these plotting functions that have a solver behind the scenes, you might have to get a little bit better efficiency by using a different method. So I pointed out, okay, you can drastically improve your plot by increasing the plot points and using a different numerical solving method, using the generic solve method. And this allowed the user to get exactly what they wanted. Now, on the other hand, this is hardly ideal because they had to use something like 4,000 plot points, and that's not great because if you were to actually run this, it would take over 10 seconds to generate, which is not something, that's not a great situation. Ideally, you would be able to generate a plot like this much more quickly. So the user got what they wanted, but it's still not ideal, and it's still not an ideal state for the software. So speaking to how technical support is kind of a central department here at Wolfram Research, in addition to just giving the user that workaround, I was also able to communicate to our developers, hey, this, even though it works technically in Mathematica 9, it's something we need to work on. And so I talked to our QA department, I talked to the developer on this functionality, and we were able to get it very quickly improved in future versions of the Mathematica. Specifically, basically within just a couple days, the developer was able to look at it, realize the problems, and fix it so that now in Mathematica 10, instead of taking, even with those additional options, it would take 15 seconds or so to evaluate. In Mathematica 10, it evaluates in 1 second or so with far fewer plot points. So the basic point is, we are able to not only get you a workaround, but we're able to get it fixed in future versions of Mathematica. And once this user kind of discovered this functionality, or this feature of technical support, we're able to get things like this improved. They were able to find other things in root locus plot that could also be improved, and they actually had 3 suggestions through to our QA and our developers that resulted in 3 improvements to root locus plot for Mathematica 10. Now this is a pretty simple example of just something that we can give people in our visualization functionality. But we can of course do kind of more in-depth developer support as well, which is something else that Peter was speaking to. So one thing that someone came through to me with is they said, okay, I have this giant piece of code, and this is it right here. Well, it's not that giant, but it's at least a somewhat substantial piece of code right here, where they're just trying to do a little bit of math in Mathematica. And they're doing a bunch of numerical integrals and whatnot in math. This was once again in Mathematica 9. And they got some error messages, but the warning messages didn't stop their code from evaluating, and so they weren't too concerned with that, even though maybe they should have been. But the main problem they were encountering was, okay, well, these numerical integrals are just taking too long to evaluate. If you look at the timing here, it's taking something like 1,500 seconds to evaluate, and that just seemed unreasonable to the user. And so in this case, they asked me, okay, well, how could how could we improve this? Certainly, tech support person, there's some way to speed up this code right here. Now, normally this is probably a little bit larger piece of code than we would like to look at in technical support, but just by glancing at it, we're able to tell this user, okay, there are in fact a few ways we can improve your piece of code here. One quick way is maybe instead of using if statements, you would rewrite your functions as piecewise functions. But that's not the biggest improvement you can make here. In fact, you can just recognize from the error messages that you're in fact encountering a common problem. And the point of this talk isn't to recognize this common problem, but the point of it, if you've ever seen these error messages before, the problem that they're encountering is that a symbolic value is being passed to an integrate. And so if you use the question mark numeric q argument to these functions, you can get rid of these error messages. And so with about 10 minutes of playing around with this, I realized that you could actually get rid of these error messages. And if you got rid of the error messages, you would speed up the code by approximately a factor of 40 or so. And so I was able to give that user that workaround. And of course, that current user was very happy with this. Okay, my code has very quickly been sped up by a factor of 40 or so. That individual user was happy. But then I was also able to recognize, okay, this is a common problem. Users encounter this error message all the time. And helping users on a case-by-case basis, that's not so great for us in technical support. And it also probably means that there's a lot of other users out there who are encountering this and not even telling us about it. They just kind of live with slow code. And maybe even users out there who don't have Premier service and we'd still like to help them. So what can we do for all those other users? And the answer is we can actually write support FAQs to inform future users of Mathematica about how problems like this can be fixed. So we've written a series of articles based on feedback we've gotten from existing users at support.wolfram.com/kb. And based on feedback we've gotten from users. And so in this case, this basically covers how you could fix error messages like this. And so you could see this is basically an article inspired by this. And this would help out future users. So we have articles for this. Another common one, for example, would be, oh, I have a large Excel spreadsheet. I can't bring it into Mathematica. How could I fix that? Well, we would have an article for that where we'd say, hey, you can just increase your Java heap space, and that would fix that problem. Because that's another very common one we see. And we have a lot of articles of that type based on our experience with other users. So we try and help both our current users and our future users at the same time by writing these articles.
So yes, my name's Michael Kelly, and I specialize in finance. I'm one of these people who has a PhD and was a professor. You may be asking yourself, why would I be doing this when I could have the great glory of teaching people boring things at university? Because it's a lot more fun. Actually, a lot more fun, much more intellectually challenging, a wide range of problems, and I can actually apply things I've learned. And the people are really interested to find the answers, not pass exams. So these type of, it makes for a much better working environment and experience. And as the others have said, there's such a wide range of people working there. They're exciting and interesting to talk to, and it's one of the best companies from an intellectual point of view. So those are the main reasons. And as they were also saying, we have a wide range of products. And it's not possible to know absolutely everything in detail. But I find this a great challenge. It means that I'm constantly learning. So there's a good, fun aspect. But I concentrate mainly on the finance platform. But that's not the only thing. I mean, I know a lot about Mathematica, have been using it for a long time. And I'm capable of speaking to people from different programming backgrounds because of my great age, I tried just about every other program before I came across Mathematica and realized I didn't, this was my true love. So that's why I'm sort of here and doing this type of area. And so as you've seen in our front end, there's so much there. So if we just went to the documentation, let me just bring it up here. And let me make it a lot bigger. There's so much here. I mean, and every time you click on anything, and then you go into anything like this. This is one of our new areas, structured data sets and the rest. It just keeps growing. I find this very interesting, and the idea is that it has a cutting edge in just about everything. So I find that it's one of the few areas where, for instance, in my own specialty, in finance, it's necessary to know a lot about partial differential equations because, say the heart of the subject would be the Black-Scholes equation. And that is really the solution of the heat equation with special boundary conditions, and that defines all the possible options you need to know. But some boundary conditions are so impossible and introduce discontinuities that you then have to turn to stochastic differential equations. If any of you work in this area, you know that there are basically finance people who just work in partial differential equations, and there are people who just work in stochastic differential equations, and they never talk to one another. Because it takes up so much time. If you really want to practice in that area as an academic, you never have time in your life to really become an expert in the other. Well, working in this environment forces me to know something about the other and how they intercommunicate. So, that's one of the benefits, I think, of this type of job. And we have both of those things. So if you go into Mathematica, we have dsolve and ndsolve for partial differential equations. And we have the Ito process function, which essentially applies Ito's lemma to stochastic differential equations. So these are very important, very powerful tools. The other thing I do, of course, besides solve these type of problems that everyone's talking about and do consulting, is that we have a very wide range of demonstrations. And if you go into our demonstration site, you'll find that there are, I think there's more than 7,000 or something demonstrations. 9,000 is, and there are hundreds and hundreds on finance. And so basically any of those that have to be updated or any new ones that come my way, I mean, I'm responsible for sort of checking through them, making sure they work, making sure it makes sense. And I'm also the default person for finance, for economics, so, they're mildly related, I guess. So I also write about those type of things and offer advice to, people who do economic analysis and econometric analysis, which means that I then have to know something about statistics. And also, you'll find that because I started off as a professor of mathematics, I'm always end up being the guy that's got to answer some problem about group theory or something like that as well. So in a particular way, I never lose contact with a lot of the things I've learned in the past, rather than just specializing in one thing. So you might have seen this before. This is one of the examples in our website, where we're looking at the surface of a volatility surface in the Heston model. So this is where you have stochastic volatility built into your option pricing regime. So, and I think this is our demonstrations website offers a fantastic way to learn basic concepts and a whole range of topics, and also to present your material. And a large part of my work actually is showing things like this to people and then convincing them that this is an interesting way either to offer a course or to explain their material to their manager or to explain it to their fellow colleagues and so on. And it's been one of our best, I think, products in terms of showing the power of Mathematica. So when I do go to a client or anything like this, we show these type of manipulate functions. All of these are manipulate functions. So you could looking at loading down some data, studying different sets of data in different ways and getting different results, looking at model fitting, and doing various tests on all of these things. So this is the type of material that you would be showing people to explain how our statistics functions work. And the notion here, of course, is that we have so many functions built in. I think now we have more than 5,000. So it's literally a complete and total language unto itself. And these type of models get across many ideas simultaneously and show the breadth of the notions that are involved. So I think this type, so for instance, this one here just shows the range of, here we've got univariate discrete probability distributions. But if I wanted to look at all, both discrete and continuous, univariate and multivariate, you can see that there's an extraordinarily large number here, and we can choose interesting ones like the Frechet distribution, and then go down here and look at its CDF and change the parameters in a dynamic fashion. So, and it also makes it possible, for instance, when you are doing consulting, and so there is a fair amount of consulting where I do for people using a Connect session. So I can be sitting at home, they can be sitting thousands of miles away, and they'd be explaining some problem that they've got. They'll give me the data, and I can sort of quickly get a quick mock-up model going using something like this. And it doesn't take me very long. And at least the idea is not to get a complete solution, but at least to outline to the client what is possible and get them some ideas as well. And I think this is an extremely powerful method for explaining ideas to clients and more or less having them realize that we're capable of solving almost any type of problem. So, just to give you, and also the other thing I should point out is the power of Wolfram Alpha too. So we often go to clients and they say, we don't use Mathematica here, and how powerful is it? And I think just showing them the power of Wolfram Alpha. So this is a program built using Mathematica and the Wolfram language, and then just basically folding in a lot of data using our pattern matching methodology and the full range of our computational capabilities to solve incredible problems. And the basic, whether or not they're going to use Wolfram Alpha, the point is it really convinces people that you can do anything with this program, that its reach is unlimited. So, so I'm forever using it and showing people we can quickly download the data to do this type of analysis. So I've just got a tiny bit of code here. But as you can see, it was a tiny piece of code just going off to some site. So, one of our clients, for instance, said, he wanted to be able to look at the Bidask spreads in the foreign exchange market for the purpose of analysing them and then building indicators that would be appropriate to this market. We already have over, I think, about 100 financial indicators, but I then went on to build something for him. And as you see here, so this is actually getting the data now. So nothing much seems to be happening here. I could update it. So we're looking at every half second. Still nothing much is happening there for the, and so while that's happening, I could go down to the next one here and look at the exchange rate for the British pound to the US dollars and see what it's doing. Again, not much. But the whole idea is that you get a notion of the spread of the values that are happening there. And you can then quickly generalize all of this so that I can say, well, okay, I'm not just interested in one of those. I can change also the rate at which it's updating and say, so being an Australian, how is the Australian dollar changing relative to the US dollar and things like that? So I'm forever moving money backwards and forwards. So studying the sort of Bidask spread, looking for those, and it's very simple then to write a program when the bid goes up and the ask remains the same, or the ask goes down and the bid remains the same, that you will respectively buy and sell. And then you can make each one of these, if you buy 1,000 or several thousands of this, you're just collecting pennies. But it's easy to do, and it's an easy way to make money, just quickly accessing this type of information. So let's see if we've got something that's interesting. See, it updates immediately. Nope, it's a very flat market today. I guess it's the end of the week. Yep, it's Friday, everyone's gone home. So there's problems like that, other types of stuff that I get involved in. So one group, they have an enormous data set. And so using our new capabilities with data set, I can then go into that and analyze it. So this is an enormous data set of about a terabyte or something like that. So I then siphoned off certain portions of it, went in, just said apply the histogram to look at, say, one of the arguments here, the final odds. And with this, of course, I can work out the distribution of winning certain, in this case it was for racing, for winning certain races. I could then go in and make queries about various factors involved in winning races. So what was the average class rating and final odds, average spread, the jockey performance, the various measures of pacing for the horses and things like this. I could then use things like estimated distribution to work out what's the probability distribution of winning horses on various tracks around the country and things like that. So this is the type of thing, a completely unexpected thing that you end up doing. And then eventually I can find what are the characteristics of winners. And you find more or less and the standard deviation of their performance. So you can get a characterization of what would be, a top winning horse. So what I'll do is just pass this on now to Anshu, and if you've got any other questions or queries, please leave them to the end, and I'll try to answer them then. Thanks very much.
My name is Anshu Manik, and I manage the technical services operation. So basically what I want to present today would be the bigger picture. So far, there have been so many talks about so many different new functionalities that have come up, and how people in very, very broad range of areas can do so much with them. My team does the work of actually aggregating the things together. Now, this is, of course, a conceptual picture of what your work may involve or what your team may be doing or an entire company may be doing as a big team. So somebody comes up with an idea, you do some amount of research, some amount of exploration, then you go through design and planning, implementation, testing. You may have to go through a loop, you reiterate, get a better solution, and then finally you go to deployment. However, some very practical problems that we face is that these different stages are being covered by different people, maybe completely different groups. And as Michael was also alluding to earlier, that in many instances, these groups do not have a mechanism, a culture, and resources to actually work together. And therefore, what ends up happening is that these different stages, they get worked on in very, very different ways. And then you have various pieces that are put together, somehow glued together, and get the thing to work. In fact, I've visited many companies, some of the biggest ones, Chrysler, Ford, CDC, Kodak, and so on. And I was surprised that just in Ford alone, for example, there are about 200 labs. And the fact is that they are using more than 100 different systems to do their work. Now, that is one kind of problem. The other problem is that even if you want to get rid of this scenario, what do you actually do? There are two things that are required. Number one, we need a technology which can span these different areas, and we need people who can actually visualize these different pieces at the same time and then come up with a system that is going to be very efficient and that is going to have a streamlined flow. Now, practically what happens is that even when you have the tools to get this bigger picture is not always trivial. In many cases, all that you actually need is some amount of help. And that's where technical services team comes into picture. So our goal is to be able to fill that gap. And over time, we have come up with the understanding that these three major offerings basically cover those gaps. Number one is advanced training. You can read it from back. Is it too small? OK, good. So in advanced training, we go one step beyond the standard training. So you may know that there are online courses available at the Wolfram training website. But then when you're working on a specific project, you have a specific group of things that you want to work on. And the generic courses may not give you enough depth to be able to work with them. At that point, we can actually help. When you come to us, you say, we are working on such and such project. We do not know where to start, or we do not know how the pieces fit together. We can sit with you. We can train you in those relevant functionality, help you actually go through that project from our side. It's customized to your needs. It goes with the pace that you want, and take only as much help as you need from us. You are not required to buy a package as such. So you can buy just 5 hours or 10 hours or 30 hours. There are companies who buy several days' worth of training for their employees and so on. The second offering is development support, where we work with you. And to the extent that you need help, to that extent we will go. So let's say that you're doing design work. We would provide recommendations. What will be good design? Let's say that you're actually doing coding. We can do some amount of coding for you. But you will have full control over what actually goes into the solution or the project that you're doing. We provide recommendations, and then you choose, and the solution that comes out is, of course, yours. The last offering is project support. Let's say that you don't have the time or the personnel to be able to complete a certain project. We can take the specs from you. We take the data. We do an entire implementation, and then we deliver. Now, I'm going to show some examples, and these are basically to spark your imagination, project ideas, so almost any kind of data analysis work that you may be doing. Of course, Wolfram Language has very powerful functionality to do them. And in those instances where you may not be very aware as to what kinds of things can be done with that data, come talk to us, and we can give ideas, because we have a team that works together. They're experts in different fields. But then because we are working together, we can actually do very amazing things. And that has been the history so far. You're doing any kind of statistical modeling, simulation, image processing, almost any kind of automation that you want to do, you can come and talk to us. So here are some examples. And this is interesting, actually. An orthopedic surgeon, somehow he came to know about Mathematica. And he was working on this problem, which is a research problem, but at the same time it is being practiced. That this is the human humerus bone. So it's from the right hand, I think. And the angle that this axis makes with the top axis, that basically tells them a whole lot about the health of this bone. There may have been an accident. There may have been some amount of damage. And the way they measure it, that angle is called retroversion angle. And that's obviously measured through X-rays. What he wanted to do was he wanted to get a feel for exactly how these X-rays give out these angles. Is it that it is an angle that they'll get no matter who tests it? Or is it that in different accidents, even if the damage was same, the angle will come out to be same? How do you do this kind of testing? You can't have people get into an accident, come to my lab, and let's see if the angle is same or not. Of course not. And that's why he approached us. Now, of course, none of us are doctors here. In fact, at some point I had decided I'll be, but when I went to my college and I took my first biology class, within 2 weeks I was pretty clear that's not the field I can follow. So, but then here's a doctor talking to me, and he's talking his language, I'm talking my language. What we did was we sat together I got all the details from him, and we came up with this tool within just 15, 20 hours of work. And this has done wonders for him because, number one, he can actually go through different views of this humerus bone and see how the alignments actually fit together. Not only that, in his field, there is a lot of research going on, excuse me, with what should be the criteria for choosing these axes, because there is no universal definition, right? So we implemented this option box for him where he can go ahead and choose the axes, and actually he can make a combination of the different protocols that are being used currently. And then he basically, now let's look at this angle. So if he goes ahead and basically uses another protocol, you see that the retroversion angle is going to change. This tool gave them a lot of insight as to the diagnosis process that they're following today. That's actually robust or not, and the answer was it's not. But then for the patients, it's very, very good news. Now, initially, nobody would have thought that computation can be used in diagnosing a disease related to human humerus bone. But because he started talking to us, here is a solution that now he has presented in two different conferences, and it has been received very, very well. Here is another example. It's a very simple example, and it is on purpose that I'm showing the smaller examples first. Company approached me. They basically have big jobs that get assigned to a lot of machines, and they need to do scheduling. But scheduling is not as simple as start and finish. There are probabilities associated with that, and there are dependencies associated with that. One bar basically represents one job on one machine, and these different colors, they represent different stages and probabilities. The problem is, if they want to see where they are, how would they do that? Is there a tool that can just plug into their environment and give them this kind of visualization? Actually, no. We actually developed this interface for them within hardly 10 or 12 hours. And now they can go back and basically check at any point. Let me see. So they can check at any point what's happening with jobs related to a particular group or jobs related to, let's say, a particular machine, and almost all kind of scenarios that they may want to. Now, this is actually a custom tool for them. They could not have purchased it off the shelf. But now, just because they have this tool in hand, their life has become much easier. In fact, you'll be surprised, and it may seem obvious at the outset, and when we are looking at things from distance. If you look at this pie chart, when they saw this pie chart, they were super excited because they had spent enormous amount of time making sure that the jobs are scheduled in such a way that there is proper distribution of those jobs across the machines. But they never had a very clear picture as to how successful they have been in doing that scheduling work. This gives them a very clear picture that actually what they did was pretty good, but they couldn't have actually known even if there was a problem unless the problem was very big, that they need to improve. Now, having this tool, they can do that very easily. It took us just some amount of time, and now they're actually going to implement this in their production system. Let's go to, well, this you have seen, so I'll skip. Here is another one. Now, many of you may have attended talks on time series modeling, time series forecasting. Let's say that you're working for a certain company, they're working with sales data or any kind of data that basically streams with time. If you do not have time series background, it's actually intimidating even to try a modeling, even if it happens to be an automatic, automated model chooser. Still, you will be hesitant. And that's what this company was facing basically. So they wanted a custom tool for their data set which is just going to give them forecasts, and the employee, they don't have to worry about knowing time series. So this is something that we created for them within like 8 or 9 hours of work. Oops. Oh, maybe I have, no. I didn't put the data set here, and that's why it's not getting the time period. So what it does, we can see from here is, the user just needs to browse through to a data set, data location, imports it, then he chooses the product. Of course, it's a very large data set. He chooses the product line, and then Wolfram Language basically chooses the correct method, gives him the forecast for next few days. He can select the period according to the needs. Now, this interface is an application in itself. The end user does not need to know anything about programming. If he can point and click, he can use this tool. Now, consider your situation as an engineer. Let's say you're doing this kind of work. What happens is if you're doing time series modeling, every single time that work comes to you, right? And then after some time, it's too monotonous, it's too boring. You want to do something new. You want to grow in terms of intellectual abilities. You want more challenges. You create this tool, give it to them. They can continue using as you can start doing things which are more complex, which are more challenging for you. In fact, this is interesting. This came to me from a Christian priest from Faith and Grace org. Basically, when sermons are going on, they videotape them, but then they want people to be able to see the verses that the preacher is talking about. And he wanted that there should be a very, very easily usable tool that he can handle while he is doing the videotaping work itself. And we came up with this tool for him, which basically has entire Bible hidden behind it. It's a CDF file. Of course, right now I'm running it in a notebook environment. What we delivered is a CDF file. He can go ahead and pick and choose the particular book that the priest may be talking from, the chapter, the verse number, and so on. How much time do we have? Almost over? Okay. Okay. This is the second last example, I think. And then he can go ahead and display that. And this is a floating screen that he can put on his recording device. His control panel can be on one screen. This can be on another screen. And he is videotaping at the same time. Now, who had imagined that a Christian priest would be using Wolfram Language? The only thing, the only gap was that he had to come and talk to us. That happened, and he has this tool. In fact, he is attending the conference here. I took permission from him to demo this. Now, they are very happy because they have the custom tool in their hand, which otherwise obviously is not available in the market. Now, the examples that I showed so far, they are smaller examples. But in those instances where your work may actually involve several stages in processing, then what do? You can develop entire applications. Oops, sorry. You can develop entire applications in Wolfram Language. And as you can see in this case, there are several steps involved here. So whatever the product line is, let's say that's 0.1. Let's say that's 1,000. He can, then there may be different options that the person has. He can do clear all or choose all, or he can select or deselect any particular ones that he wants or doesn't want. Save choices. Similarly, he will be able to choose options here and so on. Let's save. There may be other parameters involved. Then there may be a next stage where he's choosing scenarios. This is actually risk analysis that is being performed here in the background. So he chooses these scenarios. Then he needs to put in more amount of data which are relative to the specific stages in the process. So he needs to specify how many stages. So let's say if I said 5, then he can go ahead and put in these entries, or he can actually load these from a file, or he may add special units to this. Now, I'm not going through filling all of that because that'll take time, but he can add special units, which actually requires a different kind of processing altogether that allows him to specify how many special units are there, let's say. So in this way, now you can see there are so many different stages that are involved in this case, but then all this has been built using Wolfram Language. Advantage, there are generic softwares for generic work that we do, but there are very few specific softwares which can do this kind of work, which actually spans many different areas. That's the platform that we intend to offer. That's the platform that we are offering. And to put this kind of work together, to create such tools, and then be able to do great things with those, that's what we try to do with our customers. So if you have pretty much any kind of project in mind, you do not know where to start, you do not know what different pieces are or how they can work together, come talk to us, and we can work together. So let me go ahead and close this. The last slide. The expertise that's available in this team basically covers all these areas, but what I am most proud of is that we always try to understand customers' needs, and we have been, I can say proudly that we have been able to take care of their situations in almost all the cases, but in majority of the cases, we have been able to come up with ideas and solutions which were beyond their imagination. Now, because there is a team, I would call it a very rich team, who is working for them, and therefore that's my appeal to you, that you come to us, we'll help you do great things.